Hello students, today we are going to discuss about the kinetic theory of gases. Kinetic theory of gases, one of the most important for NEET. Why? Because it is a very small chapter and we'll for sure we'll get one question from this chapter. So in kinetic theory of gases, first we are going to discuss about the postulates of kinetic theory of gases. Postulates of kinetic theory of gases we are going to discuss here. What are the assumptions we take to study this theory of gases? Nothing but postulates of kinetic theory of gases. So let us assume one container we are having here. We are having container like this. In this container, what we are having means we are having gas molecules. We are having like this. We are having different gas molecules. Like it can be any shaped. So what is first assumptions? Gas molecules can be any shaped. That is first assumption. So what we can take? All gas particles have different shape, and if you observe size also here, these are different sizes, different shape and different size. Second postulate, what they're telling means these gas particles can move randomly in any direction. They can move like this, they can move like this, they can move like this. In any direction they can move here. That is second postulate. So what is telling second postulate means all gas particles can move randomly in any direction. This is second postulate. Third postulate, what we are going to discuss here means third postulate, whenever these gas particles are going and striking on the wall, they can create pressure actually. That pressure is equal to how much means 1/3 times the rho into Vrms square. Here Vrms stands for root mean square velocity, rho stands for density, and here P stands for pressure. So whenever gas particles strikes on walls of a container, whenever gas particles strikes on the walls of a container, what will happen? They exert pressure on the walls. They exert pressure on the walls of a container. How much is that pressure they given here? So pressure P equal to 1/3 times the rho into Vrms square. And if you observe here, these all gas particles are moving. We define here. These all gas particles moving means what we can tell here means we can tell these gas particles having different energies. That energy of gas particle depends on what means temperature. Therefore what we can tell means fourth point, the energy of gas particles depends on temperature. How it will vary means temperature U equal to what will get it? 3/2 kBT. U equal to 3/2 kBT will get it. Where U is nothing but energy, kB is nothing but what, Nana? Boltzmann constant. kB can be written as what here? Boltzmann constant. And where T is called what? Temperature, we can call it as temperature. Basically this should be called as absolute temperature, means it should be Kelvin system. And what is the Boltzmann constant value means, generally we can use for calculations 1.4 into 10 raised to minus 23 joule per Kelvin. We have to write it here. So first point, what they're telling, all gas particles have different size and shape. And second point, what they're telling, all gas particles can move randomly in any direction, they're telling. And whenever gas particle strikes on the wall containing, they exerts pressure on the wall. How much is that pressure? Pressure is equal to how much? Pressure P equal to 1 by 3 into rho into VRMS square, where rho is called what, Nana? Density, and VRMS is nothing but what? Root mean square velocity of that gas molecule, you can tell here. And the energy of gas particles depends on what here? Temperature. The temperature is nothing but which temperature? Absolute temperature. And Kb is nothing but what here? We can call it as Boltzmann constant, which we can call it as, that value for calculations we can use 1.4 into 10 raised to minus 23. Exact value can be written as Kb equal to 1.38 into 10 raised to minus 23 joule per Kelvin, which we'll get it here. Now what we need to discuss means, next we need to discuss velocities. 4 types of velocities is there now that we have to discuss. Let me change the slide. So what we are going to discuss here, we are going to discuss about the speeds, all 4 types of speeds. Four types of speeds of gas molecules. So we are going to discuss 4 types, Nana. RMS velocity, most probable velocity, these are all things we are going to learn here. So in first of all, what we know means, we know that pressure exerts on the walls is how much we learned? Pressure exerts on the walls, P equal to what we know? 1 by 3 into rho into VRMS square. So we'll keep this formula aside, it will help for the deriving VRMS value. So first, what is meant by V average we have to calculate. You have to know what is meant by V average means. First let us consider V1, V2, V3 up to a Vn be the n number of particles. N is the number of particles here. Okay. Then second point, what we need to calculate means V average you need to calculate. V average means average velocity. How to calculate average? Add this all velocity, divide by the quantity. V average can be written as V1 plus V2 plus V3 plus up to a plus Vn divided by n, we can write it here. This is nothing but what we can calculate as average velocity. Next one, what we need to calculate means VRMS we need to calculate. So RMS stands for what here? Root mean square velocity. Root mean square velocity if you want to discuss here. Now how can we do this means, first we have to come from backside, square each velocity. Then what we have to do, we have to take mean of that, then we have to take a root of that. So first square each velocity. So if I square V1 square, V2 square plus V3 square up to where Vn square divided by n. What we did first, we squared V1 square, you can check here, V2 square, V3 square up to Vn square. Then what we took mean is nothing but what here? Average. V1 square, V2 square, V3 square up to where Vn square we did. Then we took average for that. There is nothing but VRMS. Now square we did, mean we did, we have to apply the root. We have to apply the root for this. This is nothing but what we can tell? VRMS velocity we can tell. Next, V most probable we have to calculate. Velocity of most probable. So most probable velocity. Most probable velocity. So what is meant by most probable velocity means the maximum number of particles or molecules will have this velocity. So how to check that means, for example, let me take one example here, one event let me take here. So in that event, first column what I am taking, number of molecules or particles. Here what we are taking, speed of molecules. So let me take one table here like this, and we'll divide into columns. Here we are having 10 molecules, they are moving with 3 meter per second. I am writing SI unit here only, meter per second. Here 15 molecules we are having 4 meter per second, 7 molecules having 6 meter per second, 5 molecules having 10 meter per second, 8 molecules having 8 meter per second. Means what are the set of the molecules here? 10, 15, 7, 5, 8. Among the set of the molecules, who is greater? 15 number of particles is group is greater. Now 15 number of particles means what we are having? So 15 number of particles and having what are those having velocity? This velocity they are having now. This is the V most probable. Most of the particles having 4 meter per second. Now that is nothing but V most probable for this event. That's nothing but 4 into 4 meter per second, which we can write it here. Now for molecule, this is mathematically which we learned here. V average, V average, V RMS, okay, and most probable, what all the things we learned here. Average means simply you have to take all the particles velocities, average we have to take. Root mean square means first you have to square it, then mean it, then take the root. And next V most probable means what you have to take the maximum number of particles or molecules with the having this velocity, nothing but what? Most probable velocity, which we can discuss here. Now what we need to discuss means, we need to discuss about the VRMS value for molecules, each molecule how much it is there. We have to discuss VRMS, VMP, V this also seen. So generally what we are having here, generally we are having pressure they given. Let me change the slide. So pressure equal to what they given, 1 by 3 times the rho into VRMS square, which they given here. So now let me check, pressure equal to 1 by 3 into rho VRMS square they given. No? Now what we need to do here, we just rearrange the terms. VRMS square can be written as what? These 3 will go to numerator. So 3p by rho, which we can write it here. I want to take square on both sides. So here square root will get cancelled. Here what will get? 3p by rho. 3p by rho. This is one main formula for what? VRMS. Frequently they will be asking numericals and VRMS only. Now you know that ideal gas equation. Ideal gas equation. So what we know ideal gas equation? PV equal to nRT we know. So where n is nothing but what? Number of moles, that can be written as given mass by molecular weight. RT we can write it. Therefore pressure also can be written as RT by capital M and small m by capital V. And switching this V here, it will come to denominator here. Okay. So mass by this value, mass by volume value can be written as what here? Density. Therefore pressure equal to what we can write it? Rho RT by M we can write it here. Switch this rho here to LHS side. P by rho equal to what will get? RT by capital M. So P by rho equal to RT by M, one more relation we got it. I am taking this value, I am going and substituting in this equation. So if you substitute here, now what will get it? VRMS equal to under root 3p by rho. In the place of p by rho, what I am going to substitute? RT by M. 3 RT by capital M. I am checking. So fine. Now we are having VRMS, two equations we are having, and you know that kinetic energy, just now we proved kinetic energy of the gas molecule can be written as what? 3 by 2 kBT, we can write it here. So 3 by 2 kBT, therefore Ke equal to what we can write it here? 3 by 2 kBT we written now, where kBT is nothing but what? Kb is nothing but Boltzmann constant and T is nothing but absolute temperature. That should be in terms of Kelvin, which we can tell here. Now kinetic energy can be written as what? Half mv square. But basically this velocity is what means RMS velocity only we are taking here. That should be equal to what? 3 by 2 kBT will get it. This half will get cancelled. So VRMS square, if you want to write it now here, what will get it here? 3 kBT. So this mass will come to denominator if I switch to RHS side. So what will get? 3 kBT divided by small m, you will get it here. Therefore VRMS can be written as what here? Under root 3 kBt, which we can write it here 3 kBt by small m. So in the place of Vrms, so again one more equation we are getting here, Vrms equal to what we got it, under root 3 kBt by small m we can write it. And you know that PV equal to nRT, you know. And if n value, number of mole value they given like 1, what will happen? This n will become 1, PV equal to RT. You observe this equation come to top. So here RT is there, in the place of RT what we can write it PV. So that it can be written as what, under root 3 PV by capital M we can write it. So Vrms, what all the most probable equations we can frame, I framed it here. Let me conclude that thing, Vrms. So first equation what you wrote, 3P by rho. So let me write that thing, 3P by rho, where P is pressure and rho is nothing but density. That equal to, one more thing what we derived here, under root 3RT by capital M. That equal to one more thing what we derived here, under root 3PV by capital M. And one more thing we derived here, under root 3 kBt by small m, we'll get it here. Small m is nothing but what? Given mass. Capital M is nothing but molecular weight, which you can tell here. So this is Vrms we written here. So we need not to derive for every particle here. So Vrms, RMS means what? S, M, R. 3 letters is there. Now just remember like the short trick. 3 letters, 3 you will get it here. Similar way if they ask you to derive for V most probable. Now how to derive that means? No need not to derive. Just remember that V most probable can be written as. So every formula remains same only as it is. You just have to change what? In the place of 3 we have to write 2P by rho. In the place of 3 we just have to keep 2. You have to remember like short trick. This is 1, this is P. This is nothing but two letters. Now you can remember like that. So let me conclude that formula here. V most probable can be written as under root 2P by rho. That equal to what we can write? 2RT by capital M. That equal to what we can write it? Under root 2PV by capital M. That equal to under root 2 kBt by small m, which we can write it here. 2 kBt by small m, which we can write it here. These are nothing but forms of the V most probable. And now we can write for the what? Velocity of the average also we can write it. V average can be written as what? Means in the place of 3 and 2 what will get here means 8 by pi P by rho you will get it. Similar way velocity of the sound if you want to check here, what will get it here? Under root gamma by P by rho. In RMS what will get it? 3 will get it. In this fellow 2 will get it here. And next most probable will get as 2 and average will get like 8 by pi. Next volume of the sound means what will get it? The same coefficient will get like gamma here. So let me conclude here. So what we are going to conclude is these are all the velocities. Let me write neatly here. So how to write neatly? Let me check here. Vrms we written here Vrms. So let me change the slide. So Vrms equal to what we derived? Under root 3P by rho. First formula which we derived. Another one what we got it? 3 PV by capital M. Another one what we got it? 3 RT by capital M. Another one what we got it? Under root 3 kBt by small m. Small m is called molecular weight and capital M is called what? Given mass. Grams they'll give that mass. Next we need to conclude about the V most probable. V most probable is nothing but what will get it? Under root 2P by rho. That equal to under root 2 PV by molecular mass, and this is nothing but 2 RT by capital M, and this is nothing but 2 KT by small m given mass. Similar way we need to write about the what? We need to write the average. In the place of 2 and 3 what I would like to conclude here? 8 by pi I told you. 8 by pi times the P by rho. That equal to 8 by pi times the PV by capital M. That equal to 8 by pi times the RT by capital M. That equal to 8 by pi times the KT by small m, which we can write it here. Now velocity of the sound also we have to study basically this thing in waves chapter. I am going to conclude here only since we are learning here now. So let me discuss here only. Gamma will get it, adiabatic constant. Gamma P by rho. That equal to 8 by pi so what will get it here? Gamma P V by capital M. That can be written as what? Gamma times the RT by capital M. That can be written as gamma times the KT by small m, which we can write it here. This is how these 4 set of the formulas we can conclude here. So what all the numericals will get from NEET and CET, these are 5-star formulas. They cannot cross here from here. JEE, NEET, what all the numericals is, they can give from here only. For all JEE and CET and NEET numericals you will get from this for sure. Every year one JEE question they are going to ask you, and in the among these all VRMS velocity is very important, and among these all this formula plus this formula is very useful so while solving the numerical, which we can tell here. Now we need to conclude one graph here. What is that graph means? Maxwell's distribution curve we need to discuss about here. Maxwell's velocity distribution curve we are going to discuss. So what we are going to discuss here? Maxwell's speeds distribution or velocity distribution. Speeds distribution curve. So Maxwell's speeds distribution curve we want to study here now. So Maxwell's he explained one graph. He given one graph like this. Here they mention number of particles or number of molecules. Here speed they given, that in terms of meter per second we can write SI unit. What they given means, he given one graph like this. Now if you observe here now, among these 3 speeds, which speed is greater first you have to conclude. So then we are going to mention in the graph here. So which speed is greater means, if you observe here now, VRMS value is nothing but root 3 na. So root 3 means what we get? Root 3 value is nothing but almost 1.73. So 1.73 times the P by rho we know, and root 2 value is how much? 1.41, and root 8 by pi value is how much means 1.66 you will get it, 1.66. Among these 3 which is greater? 1.6 or 1.4 or 1.7 means 1.7 is greater. 1.7 corresponding to what? Most probable, sorry, V root mean square value, and this corresponding to what? Most probable, and this corresponding to what? V average. Now among these all, who is greater means VRMS is very clearly it is greater. That's why we are going to mention in the graph here. So most of the particles is there now. There what will be there means VRMS will come. V root mean square. Next second to that what will be happen? 1.6 is the second greatest one. So second one you will get it like this. So 1.6 is you will get it here. This is called what? V most probable. No, V average will get it. 1.66 is nothing but V most probable is nothing but final one what? No, V most probable we got it. So third one we are going to represent like this. So least who is having means V most probable we are having. So for example, if they ask you ratios, no, V RMS is to V average is to V most probable is equal to what we can write. If you observe now here, P by rho, P by rho is common. What we can write it here? Root 3 is to root 8 by pi is to root 2 will get it. This is nothing but ratio of velocity of RMS to the most probable. They can ask you direct questions from here. And one more thing what we can tell here means, we can tell who is greater. It's very clear from the graph, and I mentioned values here. VRMS is greater than V average, that is greater than what we can tell V most probable. So many places they can ask you direct questions also from here. But basically if you observe now all NCERT and other standard books, many questions we can check for root mean square velocity. Many questions we can check for what? Root mean square velocity, which they given here. Fine. So now let me go into next slide. In next slide what we are going to discuss here means V most probable velocities we have discussed in here. Next slide we are going to discuss about the law of equipartition of energy. Law of equipartition of energy we are going to discuss here. So name itself is telling here law of equipartition of energy means energy distribution nothing but law of equipartition of energy. Law of equipartition of energy. It explains about what? Concept of energy. Concept of molecular energy or internal energy or kinetic energy. Everything is same because molecules we assumed here, they are moving here. Fine. Now what we are going to discuss here means what does the statement will tell? Let me discuss. Statement. So what does statement it tells means the energy associated with each molecule per degree of freedom is half kT, they told. Means half kT, where T is nothing but absolute temperature and K is nothing but Boltzmann constant, which we can tell here. Half kT. This is for how many molecules? 1 molecules. So for if I take for example monoatomic gas, like examples like helium, argon, these all having 3 degrees of freedom. Degrees of freedom is how much we learned? 3. So for each degree of freedom, how much? Half kBT. So for 3 degrees of freedom, how much energy we can write it? 3 by 2 kT, we can write it here. For example, diatomic I am taking. Diatomic gas. Diatomic gas such as O2, N2, okay, and Cl2, these all things we can consider. These all things having degrees of freedom, how much means? These all things having degrees of freedom, 5 degrees of freedom. Among these 5 degrees of freedom, 3 is for, we studied the translational, 2 is for what? Rotational, we given here, degrees of freedom. So energy per molecule is how much? Half kT. So for this complete molecules, what we can write it here? 5 by 2 kT, which we can write it here. Next, what we are going to discuss here means diatomic gas is done. Next, we are having triatomic gas. Triatomic gases. For triatomic gases, what we will get it here? For triatomic gases, or this can be called as polyatomic gases also. How many degrees of freedom will get it? Generally 6 degrees of freedom. This is for 3 translational. This is for what we can tell? 3 rotational. Therefore, that is nothing but such as H2O and NH3. These all things we can come under this thing. So what we can take here? Energy can be given as internal energy or energy, kinetic energy, both are same. 6 by 2 kT, we can write it here. This is generally which we can write for the boards level. So the same questions which they can ask here, NEET level also, that we'll discuss in the next section. Okay, this is for today's class. Thank you, and please do revise once again for better performance.